There we go. Okay. So the first thing I want to say, again, Darlene, Layla, I see that you're on. Make sure you both take practice exams and then schedule your one-on-ones with me so we can get those, so we can try to get these tests out the way. Okay.
Okay.
So I got a bunch of questions that were sent to me or people had issues with. So I want to make sure I go over them. Like that, Destiny sent me a message in terms of formulas. Okay. What I want you to prepare is how to use that formula sheet. So if you look on this, this is not a great picture. The person who sent it to me, question 19 says, Laura's painting model pyramids for an art project. She needs 1 tube of paint for every 30 square inches of surface area. If Laura paints each pyramid in its base, approximately how many tubes of paint should she buy? And most people look at that question and be like, where do I even start? So first of all, let me ask the class a question. What's important in that paragraph? What do we know?
We know it's a surface area.
We know it's a surface area problem. What else do we know?
We know it's 30 square inches.
So we know each tube of paint is 30 square inches. What else? And what's the last two things that we know? Shape. Shape. It's a pyramid. It's important that you identify those three things. Now, the last thing that we know is these are the three pyramids here. Now, you can't see them all. So let me see if I can scroll it down a little bit, see if we can see it. There we go. Let me make it a little smaller here. Let me clear it real quick so we can see all the pyramids. Come on now, why don't you not decrease it in size? There we go. There we go. That's enough. Okay, so right away, I'm gonna tell you like this. I'm gonna look at the biggest pyramid and I'm gonna say, you know what? A pyramid, we have the formula for a pyramid to find surface area. Now, what is surface area? Surface area is not volume, that's not inside. So surface area just means the area of each side of the shape. Okay, the area of the surfaces. That's it. Now, if we look on the formula sheet, so we got the pyramid, we want surface area. So what we're going to do is we're going to go to our formula sheet and we're going to find my formula. So we got a pyramid here, surface area is right there. So SA, I'm going to write it down here, surface area is equal to 1/2 P and S. Well, what is P? I don't know what P and S are. So it tells you right here. P is your perimeter of the base. And see, P equal perimeter of base with area B. And then your S is your slant height. Now, I can tell you right now, you probably, if they're going to give you a surface area problem, they're going to either give you a sphere or a rectangular prism. But what's important is it doesn't matter what type of problem they give you. You have to identify what's important, go get the formula, and then all we're going to do is plug it in to our calculator. That's what's important. That's what I need you to understand. So let me move some of the stuff so it's not as clear. Let me erase these squares here. We have our formula. So right away, we do 1/2. Oh, I forgot. I didn't write the whole formula down. Wow. It would be nice if I wrote the whole formula down. Plus B. It would be nice if I wrote the entire formula down. And B is the area of the base. Okay. So now watch this. So all we're doing is identifying what we know, and then we're plugging it in. Let me move this again so I can make it clear here. Move all this up here. Again, all we're doing is identify what's given in the problem, going to our formula sheet, identifying the formula, and then all we're going to do is plug in. So all we're going to do, 1/2 PS, so the perimeter. What's the perimeter of this base here? What's the perimeter? If each side of that square is 4, what's the perimeter?
32.
Not 32. What is
16,
perimeter?
sorry.
16. So the perimeter of this is 16. So here we got the perimeter is 16. Here our perimeters what for the second pyramid?
12.
12. And what's the perimeter of this first pyramid?
8.
8. If you did not know how to find the perimeter, I'm going to tell you right now, you don't worry. The perimeter is the distance around. You need to know how to find area and perimeter of all those shapes. So the perimeter is just adding around. So what causes people problems are, well, I only have 2 sides, Mr. Tensley. No, you don't. What they're telling you is when you see that both sides are the same, they're telling you the base of this shape is a square. That means all sides are equal. So here we got 4, 4, 4, and 4. That's how Brandy got the 16. Here we got 3, 3, 3, and 3. Now, what you should know is if you got a square, perimeter is just multiplying one of the sides by 4. So 3 times 4 is 12, 2 times 4 is 8. So those are the 3 perimeters of those shapes. The slant height, they give it to you. Slant height for this one is 3. The slant height for this one is 6. And the slant height for this shape, for this pyramid is 4. Now, the area of the base. Okay, so we look at that base, length times width. And for a square, length and width are the same thing. So 2 squared or 2 times 2, our area is what for the first pyramid? Anybody know? What's the area of this first pyramid? Of the base. So this shape at the base, what's the area of this square of the bottom of this pyramid?
Is it 8?
It's not 8.
4?
It's 4. 2 times 2 is 4. For this shape, what's my area of the base?
9.
9. And then for this last shape, my area is what?
16.
16. Now, what I did was I took all 3 things. Now, I can guarantee you're not going to have something this hard on the GED. They might ask you for 1 pyramid. They're not going to ask you for all 3. I can almost guarantee you. But now I'm going to go to my calculator because my calculator is my friend. So what I'm going to do is I'm going to put this in for each one, for each pyramid. So ND, 1/2 times my perimeter, which is for my first shape is 8, times S, which is 3. Again, I'm putting in parentheses because I'm doing multiplication, plus the area of my base, which is 4. So my surface area of my first pyramid is 16. So my surface area of the first pyramid is 16. Okay, now I'm gonna do the same thing over for the second one. Now I'm not gonna write it all over since I have it there already. All I'm going to do is I'm gonna go back up into my formula. I'm gonna change my 8 to a 12. I'm gonna change my, again, so 1/2, my perimeter is 12, my S is 6, and then the area of my base, which is 9. And I'm gonna press enter.
Yeah.
So my surface area of my second pyramid is 45. And I'm gonna do the same thing for my third pyramid. I'm gonna go up to my formula, I'm gonna press enter. So my P for the third one is 16. So now I only gotta change this 2 to a 6. My slant height is 4. I'm gonna change that 6 to a 4. And then my area to base is 16. So I noticed that my surface area for my third pyramid is 48. So now I must add all those up because I need the surface area of all 3 pyramids. So again, I'm gonna take my 48. I'm gonna add, again, since the last thing I did is stored in this calculator. First of all, let me take a screenshot so you can see it. I'm just gonna add 48 plus 45 plus 16. And I get 109. So In total, I need 109. That's not the answer to this question. The answer to this question is how many tubes of paint should she buy? Well, what we know about each tube is that it can cover 30 square inches. So we're going to take that 109 and we're going to divide it by 30. How many tubes do I need? 3.6. Well, that's not even an option there. 3 is not there. Why? Is because you would need 3.6 tubes to cover that entire surface area. So if you bought 3 tubes, that wouldn't be enough. So how many tubes should you buy? If you needed 3.6 tubes of paint, how many tubes should you buy?
4.
4 tubes. Okay, now I can almost guarantee you're not going to have something this difficult. I believe this is from the Kaplan book, but again, that doesn't mean you shouldn't be able to solve it. Any word problem you get, you got to break it down into steps and be able to solve that question. So again, first we found the surface. First of all, we identified the shape, which was a pyramid. We identified what's given. So in the first shape, we identified the perimeter was 8, the slant height was 3, and the area was 4. We then identified the perimeter for the second pyramid was 12, slant height was 6, and the area was 9. And then we did the same thing for the last pyramid. Perimeter was 16, slant height was 4, and then area was 16. We then used our calculator to plug it into our surface area formula so we can find a surface area of each one. And then we added those to find a total surface area that we would need. And we got 109. So then you should have realized that each tube, that's important, will cover 30 square inches. So all we're going to do is divide by 30. Or you could have figured it out like this. Okay, I need 30, 30, 30, 30s for a total of 100. It would cover 120 square inches. So that's a way you could have did it too if you didn't know to divide by 30. Okay. Now I doubt if you're gonna have something that difficult. The GED is more straightforward. They might just ask you what's the surface area of this pyramid, or the surface area of this sphere, or the first surface area of this rectangular prism. Usually it's just one shape, not 3. So, but again, identify your formula, identify your givens, plug into the calculator. That's what you want to get in the habit of. Now, the second one person sent me was this. And so I want to ask the class. Now, this is, you probably won't see something like this on the GED. This is in your Kaplan book. If you're taking the task or the high set, you may see something like this. But if you're taking the GED, you probably won't see something like this. But that doesn't mean we shouldn't be able to solve it. Okay. Now, I have no idea how to solve this problem. Can somebody help me? Where should I start with this problem? So it says, use your calculator to make the following calculation. In the figure above, a square contains a circle such that each of the sides of the square is touching a point on the circle. What is the area in square inches of the shaded portion? So they didn't ask you the area of that square. They didn't ask you the area of the circle. They want the area of the shaded region. If you can understand this problem, you can probably do any area problem that they're going to give you on this exam. How would I start a problem like this? Like, I don't even know where to start. Where should I start? Can anybody help me?
Do we need to find the area of the circle first?
Okay, so first of all, we should identify what's given first. That's how we want to start off. So what do we know from this?
We have a circle and we have a square.
Okay, we have a
Right.
circle and a square. But what do we know? What information do we know from that circle and square? What is this right here?
The radius.
Radius. So the first thing we know is that we know the radius of the circle is 2 inches. Now, let me ask you a question. If we know that the radius is 2 and this touches here, right? This length here is called the diameter, correct?
Yes.
What will my diameter be?
4.
4. What you also should notice by figuring out the diameter from here to here, you also find
Yes.
the side of the square. So the side of the square is also what?
4.
4. Does everybody understand that?
Yes.
Is there anybody here that does not understand how we got the side of the rectangle or side of the square 4 inches? Okay, great. So this is what's important. That's the most important step in this problem. Identify what's given. Okay, so we have the radius is 2, we have the diameter is 4, and we have the side of the rectangle or side of the square is 4 inches. Okay, so how do we find that? What's our next step to figure out the area of the shaded portion? How can we find
Will we times
Time.
it by 4?
times what by 4?
The 4 by 4 or no?
Okay, so the area of the rectangle
So I was thinking it would be 16.
is 16 because we got 4 on this side and we got 4 on this side. How do we know? Because this point is also the diameter. So this side is also 4. So it's a square. So the rectangle is 16 inches squared. Perfect. I love that. So we found the area of the rectangle, but that's not what they want. They want the area of the shaded region. What else do we know? What else can we find? What else can we find? Okay, let me ask you a question real quick.
We done
And-
the
and-
perimeter?
Watch this. I want to show you something, right? Okay, so if I tell you this is filled with, I don't know, I'm just gonna make something up, 20 fish. This is filled with 20 fish. This whole entire rectangle is filled with 20 fish. Okay. And then I tell you on this side of this fish tank, there's 16 koi. So if there's 20 fish in the entire fish tank, and there's 16 koi on this in this area that's red, how many fish are left on this side?
4.
4.
Okay, well, what did you do to find that? How'd you get that 4?
Subtraction.
Subtraction.
Yeah.
So that's similar to what we want to do in this case. Find the area of the rectangle, what the circle is inside the rectangle. We find the area of the rectangle, which was 16, and then how do we find the area of the circle? What is the formula to find area of a circle? Does anybody know? If you don't, please.
Pi r square.
Pi r squared. And where did you get that? Did you commit it to memory, or where could you look if you didn't know the area of a circle?
On the formula sheet.
On the formula sheet. So again, I just want to show it real quick. Oh my goodness, it's a whole lot of mess here, but hold on. Let me clear it for a second and I'll give it right back. Again, because I want to explain. You don't have to remember all these formulas. You just got to know when to use them. So area of a circle. So again, in this first section, this is all the area section. We found a circle, pi r squared. So you don't have to remember everything. Okay. So now let's go back to that problem. Let me hit undo real quick so we can get that stuff back on the screen here. Okay. So pi r squared. What is pi? Can somebody tell me what pi is?
3.14.
3.14. And what is the radius of that circle?
2.
2. And what is 2 squared? How do we figure out 2 squared?
4. 2 times 2
4.
is 4.
Okay, so we got 3.14 times 4. Now, again, we could put this in our calculator. That's what I'm about to do. But let me erase some of the stuff on the left so I can put the calculator on the left side. And this is important that you understand. Oh, some of these are step by step. You may have to do one thing at a time. So what we did was, first of all, we found the area of the rectangle, which was 16. Now we want to find the area of the circle, which is 3.14 times 2 squared, which is 12.56. So if we know the area of the rectangle, We know the area of the circle. How can we find the area of the shaded portion?
We'll do subtraction. We'll do 16 minus 12. And whatever left, that's the shaded area.
That's the shaded area. So look what we did. So understand. So you have to break this down. We have to use critical thinking here. We know how to find the area of a rectangle. We know how to find the area of a circle. But that shaded region is the area of the rectangle minus or subtract the area of the circle. So we get 3.14. Let's look at the answers that's available. Oops, didn't mean to do that. Sorry about that. The answers that are available. And we got that A would be our answer. Now, Mr. Tinsley, I can't remember all that. I can't remember all that. Let me show you something. Watch this. Now I'm going to show you the common sense way. Once I realized that this radius is 2, I know my diameter is 4. So I know my side of this square is also 4. Correct?
Mm-hmm.
So the first thing I'm going to do is find the area of that square, which is 16, right? Now, that would be the entire square. So if I'm only trying to find the shaded amount, I know it has to be less than 16, correct?
Mm-hmm.
So, bang, can't be 28. Bang, can't be 16. Now, the circle is taking the majority of that square up. It can't be close to 16 either. Bang, done. That's without doing any work. Understand what you're looking for first. If I know that my rectangle is 16, and if I want to take any shaded region inside that rectangle, it's going to be smaller. So because that circle's taking up most of that space, I can get rid of 26 and I can get rid of 16 right away. The second thing I want to do is, hold on, that circle is taking the majority of that 16. So it's no way the answer could be 12.57. So I know that answer is 3.43 without doing any work at all, without even thinking about plugging into a formula. So one of the things I want you to do is always identify what you know. Then you look at those multiple choice answers. I can guarantee whether you're taking high set, task, or GED, 2 of those can be knocked out because you know they're not even close to the answer. So if I know my answer has to be less than 16, C and D are immediately out. So even if you didn't know what to do from there, at least you got a 50-50 chance. Does everybody understand that? I'm thinking.
Makes
Okay.
sense.
Good. Okay, now another problem that some people had over the weekend. So let me just put that on the screen here. And about 5 people got number 35 incorrect. Every single person that tried number 35 over this weekend, I think it was either 4 or 5 people, every single person got this problem wrong. Okay. 2/3 H plus minus 4H is equal to 20. Can everybody see that problem?
Mm-hmm.
Okay. So before we look at that problem, what I want to do is let's look at number 34. How would I simplify 34? How would I simplify this expression for number 34?
Add up all the 6 and the 13 and the x, which is 1x, add them up,
And what's that called?
combine like terms.
Combine like terms. Okay, you want to, especially for algebra, you have to be able to combine like terms. So she said the plus x, which is 1, she said, the minus 6 and the 13. So 13 minus 6 is 7. 7 plus 1 is 8. So these 3 terms will combine to 8x. Does everybody understand that? Okay, good. Now we also combine in 9 and 7. What's 9 and 7? 16. So you have to be able to combine like terms. Well, Mr. Tinsley, I thought you were talking about number 35. The reason why I wanted to make sure everyone know how to combine like terms is because this is why people get 35 incorrect. So if I'm looking at number 35, correct? 2/3 h plus minus 4h equal 20. Where do I even start to solve that problem? Where would I even start to solve that problem? Does anybody know? Okay, let me ask you this. What if I had this problem here? 2/3 x equal 4. How would I solve that? How would I solve this problem? 2/3 x equal 4.
Do multiplication by 3.
Multiply by 3 and then what?
I get rid of 3 and we'll have 2x equal 12.
Okay.
And we'll
Okay. So what Layla said is multiply by 3 first. And then the 3's cancel here. You're going to have 2x equal 12. And then what's my last step?
divide by 2 to get
Divide
have the
by
x by
2.
itself.
To both sides to get the x by itself, we get x equals 6. So that's exactly right. Now, but what she did was she did 2 steps. What I want to explain to you is this. Watch this. I'm going to show you something. I'm going to show you something. This is very important that you understand. And this is why most people, I believe, got this incorrect. So what?
I think I was one of them, Miss Tinsley.
You were one of them?
I think so.
So what I want you to identify though is what she just said. First we multiply by 3, then we divide it by 2. So we multiply by 3 and then divide it by 2. What you should notice is if you have a fraction as a coefficient, in order to get rid of that fraction, multiply it by its reciprocal. So flip it. So what we want to do is multiply both sides by 3/2. If you notice, the 3's cancel, the 2's cancel, we're left with x equal 12/2, and we still get 6. Right? That's one way you could do it, right? Everybody understand that? If you don't know, make sure you pause this video when you go back over to make sure you know how to, if you have a coefficient as a fraction. Okay, well, Mr. Tinsley, hold on. You showed us one problem where we combine like terms. Then you showed us a problem we had to multiply by the reciprocal. Mr. Tinsley, why are you doing all this? It's because this problem here is a combination of both of those things. First of all, you have a variable h, and you have 2 terms. One has 2/3 h, one has -4, right? To me, I'm using the calculator. Who knows how to combine that? Then that's fractions. Then I have to find a common denominator. Then who wants to do all that? Remember, your calculator is your friend. What you have to recognize is that they are like terms because they both share the h. So you use your calculator. 2/3 -4. So you get -10/3. So you get -10/3 h equal 20. Right? Then what you should also notice, what I just told you, if you have a fraction as a coefficient, in order to get the variable by itself, you can then multiply by its reciprocal. So that is -3/10. Whatever I do on one side, I do on the other. -3/10. Now, what I notice is the 3's cancel, the -10's cancel, and h is equal to 20 times -3/10. Now, if we were doing this by hand, you should see that that's a minus sign, that the 10 and the 20 you can cross cancel. So 10 go into 10 once, 10 go into 20 twice. 2 times -3 is -6. That's doing it by hand. But again, what am I trying to show you? I want you to use this calculator as much as you can. So type it in. 20 times -3/10. So hit your minus sign, hit your ND, 3/10. Get out of your fraction, just closing parentheses for multiplication, hit enter, -6. This calculator is your friend. That's why in the beginning of this book, I show you how to manipulate fractions. Because when you get them, the only part of this test that you can't use your calculator for are the first 5. After that, you can use your calculator for anything a part of this exam. So here in this case, we have to combine those like terms. You have to understand the steps first. First of all, to combine them, that means no matter what my variable is, if they share the same variable, I can combine those terms. So 2/3 minus 4. If I'm doing that by hand, I gotta find a common denominator. Nobody wants to do that. If you notice, the calculator did it for me. 2/3 minus 4. I got my answer, minus 10/3. So all I have to know is I gotta keep my variable, which is h. So minus 10/3 h. So then you have to understand, okay, to get the h by itself, I must multiply by its reciprocal. That means flip it. Because as Layla said, you multiply by 3, then divide by 10. Well, guess what? That's what a fraction is. 3/10 means, -3/10 means multiply by -3, then divide by 10. Well, now, because of the calculator, we can do it in one step. So let me clear this out. Let me maximize the calculator so you can see the steps. Let me move that over a little bit. So you can see the steps in order to solve these problems with your calculator. Listen, long as for fractions, only thing you won't have to do the first 5, fractions, decimals, percents in order, and change a mixed number to an improper fraction or improper fraction to a mixed number. That's the only thing you got to be able to do for the first 5. Everything else you can use your calculator for. This is your friend. I'm telling you, this is the key to passing this test easily. Okay, but you have to learn how to do the basics, how to put a mixed number in. For example, let me just show that real quick, even though we're not on fractions. Let me just take a picture of this first. And then these are the basics that you need to know. Watch this. Let me clear everything out. So I need to know how to change a mixed number to an improper fraction. Okay, well, while I'm practicing, let me make sure I can do it on a calculator. So you're going to press the 2. You're going to hit second. You're going to hit ND. Why? Because in green, there go your mixed number. Then you can put a whole number and a proper fraction. So then you can press enter. And if you notice, it will automatically change to an improper fraction. 4 times 2 is 8, plus 3 is 11. So you can practice. Now, how do you do it the other way? Same thing. ND, 27/6. But this way, when we hit enter, it's still an improper fraction. But what if I wanted it to be a mixed number again? So ND, 27/6. And then right here, let me get out of the fraction. Right here, you should see in green, ND, arrow, arrow, UND. That means anytime you see an arrow, it's to convert. So if I want to change an improper fraction to a mixed number, that means I'm going to hit my second. I'm going to hit the times 10 to the end and press enter. Now I got my mixed number. Those are, okay, Mr. Tinsley, basics. Okay, basics. You want to learn the basics of this calculator because when you go into this test, it'll make it a lot easier for you. How you doing, Chris? Glad you can make it. I also saw Mr. Crosby. We went over both of your examples, sir. So since you just got in, they will be in the video. So you'll see what I did. Okay. No problem. I'm glad. So it was another question that I want to make sure that I share. Number 37. 3x squared times 7x to the third. I was surprised quite a few people got this also incorrect. How do I simplify this expression? Does anybody know how to do this problem?
Start X.
I'm sorry, say that again, Chris.
I can install X.
No. So here, they don't want you to evaluate it. They want you to simplify it.
Is this where you have to do to the left that you have to do to the right?
No. So
Yeah.
this is called your exponent rules that you must know. You must know your exponent rules. Okay. So when you're multiplying exponents with the same base. So both of these, what is the base of both of these terms? What is the base?
X.
3 and 7.
X. X is the base. So let's make sure we understand the vocabulary. So 3x squared. This is the 3. Oops. I don't know if I drew an arrow. That's my coefficient. This is my base. This is my exponent. Okay. So the rules of exponents say, exponents with the same base, if you're multiplying, you add the exponents. So that means x squared times x to the third is what?
5.
Not 5, x to the fifth. Keep the base, you add the exponents, 2 plus 3. What's 3 times 7?
21.
21. So to simplify this, your answer would be 21 x to the fifth. Guaranteed first 5 problems. Where they're going to have you do the exponent rules. Guaranteed you're going to have it. You got to have it. So let me go over those exponent rules real quick so we all know what those are. So let me go to a blank sheet. Does anybody know what the exponent rules are?
Is that
Can somebody tell me?
Before you go there, can you explain what was written underneath the question?
Hold on, let me go back to that problem. Hold on. Where was I? Oh, was it that one? No. Where did I have it at? Ooh, hold on. It was on the screen. Hold on, I'm sorry. Was it that one? Yes. So it says simplify the expression. So how you know not to evaluate it is it doesn't have an equal sign or it doesn't have x equals something.
Yeah, but
So
underneath it said write 3x squared as 3x raised to power 2.
right, 3 times x to the power of 2. That's how you read that. Or what I would say is 3x squared.
What does it mean? That's what I wanted to find out. What's it going to do?
So if I have 2 to the 3, remember I said this is the base, this is the exponent. And what this means is take this base and you're going to multiply it this many times. So 2 to the third is 2 times 2 times 2, which is 8. So 3x squared means 3 times x times x. So I'm going to show you something. Watch this. Times 7 times x times x times x. So 3 times 7 is 21. And how many x's do we have? 1, 2, 3, 4, 5. 3x to the fifth. So that way, if I write it out that way, then you can see why exponents of the same base, you add their exponents to get your answer. Guaranteed problem on your GED. Guaranteed. And they're probably going to mix in a bunch of the rules. So for example, let me show you a prime example that they put on the study guide. Let me find it real quick. And you have to be ready for this. It's a guarantee problem. They almost always put exponent rules on the exam. So it's something like this. Okay. So what you have to know is, first of all, the first exponent rule is that anything to the 0 power is 1. That's the first rule. Second rule, anything to the first power is its base. That's the second rule. The third rule is your multiplication rule. So a to the third times a to the fourth. Any exponents with the same base, if you're multiplying, you add the exponents. A to the seventh. Okay, understand. Remember, go with what you know. So if I know exponents with the same base, if I'm multiplying, I add the exponents. What do you think if I divide exponents with the same base? What do you think I'm going to do?
Subtract.
Subtract. So 10 minus 3 is 7. Okay, the next rule is if when you raise to a power. So again, I'm going to show you step by step. So a to the third squared means, what does square mean? So x squared means x times x. 3 squared means 3 times 3. So a to the third squared means a to the third times a to the third. Again, they have the same base. So we add the exponents and we get a to the 6. Well, what did I tell you from the first day of our class? Math is about patterns. So what you notice is when I added those, I got 6. But if you look at the relationship with 3 and 2, what you notice is if I multiply them, I also get 6. So that's the second rule, or the next rule, that anything raised to a power, you multiply the exponents. So that's the first, second, third, fourth, fifth rule. And the sixth rule that you must know is if you have a negative exponent. So for example, if I have 5 to the minus second power, okay, that is the same as 5 to the minus second power over 1. You can change any number to an improper fraction by putting it over 1. So what we do is you change the orientation. So my 1 is going to go up top, my 5 is going to go to the bottom, and you change the sign of the exponent. So when I move it to the bottom, I change it to a +2. So 5 to the negative second is equal to 1 over 25. Those are the 6 rules you must know for exponents. Okay? Now, I'm going to save it. Now, let's go look at this example. Okay? Please excuse my dear Aunt Sally. Does anybody know what that means? Why did I write that down? PEMDAS. What does it mean? What is it for?
Parentheses first. Exponent is the next step. Multiplication, division, adding, subtraction.
So those, correct. So those are the order of operations. Anytime, any expression that you see that you have more than one operator, you have to think of PEMDAS, or the order of operations. So my first thing is I go from left to right. I have parentheses, right? But in my parentheses, I can't simplify anymore. So I'm done with that. Then my next one is an exponent. I do have an exponent right there. So that's what I have to do first. So our exponent rules tell us that if you raise to a power, we multiply the exponents. So I'm going to bring this down. That's not going to change at all. But when I raise to a power, I multiply. What is 4 times 2?
8.
8. So I have 2 to the 8th power. Does everybody understand how I got 2 to the 8th power? Because 2 to the 4 raised to the 2nd power, we multiply, we get 2 to the 8. Now, there's 3 here. We also got to raise. But what we don't see, if you don't see an exponent, it has 1. You just don't see it. It's 1. If you should notice now that if anytime 1 is used as an exponent or multiplication, you don't see the 1. So in this case, 3 is just 3 to the 1. So what's 2 times 1? 2. So we got 3 to the 2nd power. So 3 to the 1st power, raised to the 2nd power, 2 times 1 is 2. So we got 3 squared. Does everybody understand how I got the 2 to the 8th and 3 to the 2nd power? Does everybody understand that? Okay, good, good. So now I'm going to erase it. I'm going to erase this portion here. I'm going to erase this here. I'm going to erase all of this here. So now we have come to this point. Remember, understand your rules. Exponents with the same base. So do we have exponents with the same base? Tell me what they are.
Two and three.
We have 2 and 3, but what 2 terms have the same base?
2 to the 9th and 2 and 8th, yeah.
2 to the 8th. Okay, what do these parentheses around both of these imply? What operation does those parentheses imply?
Multiplication.
That's division.
Multiplication. Parentheses is always multiplication. So for example, 3 times 4 is 12. 3 times 4 is 12. Once you get to algebra, you will not see that. What you will see is 3 times 4, 3 times 4, or 3 times 4. Parentheses imply multiplication. This is why in my book, after you read the first section, I don't use the multiplication symbol at all anymore. I'll only use parentheses. So you get in the habit of using parentheses for multiplication and ND for division. Now, so 2 to the 9th times 2 to the 8th. Since they have the same base, what am I going to do to the exponents? If I'm multiplying exponents with the same base,
You
what am I
add
going
them.
to do? I add them. And what is 9 plus 8?
17.
17. So 2 to the 9th times 2 to the 8th is 2 to the 17th power. Once you calculate that, you can get rid of all three of them. You already know the answer, but I'm going to finish it all off. So let's look at the second part. The second part, I have a base of 3. So I have 3 to the 5th times 3 squared. Remember, exponents with this, if I'm multiplying exponents with the same base, I add the exponents. So what is 3 to the 5th times 3 to the 2nd? Can anybody tell me?
To the 7th.
3 to the 7th. So 2 to the 7th. Now, these are not like terms, so I have to keep them the way they are. 2 to the 17th times 3 to the 7th, which will be answer D. Almost a guaranteed problem, probably one of your first 5 where you have to use your exponent rules. But in algebra, throughout algebra, you have to know your exponent rules. When you multiply binomials, you need to know your exponent rules. When you factor quadratics, you have to know your exponent rules. This is an important part of algebra. You can go to my site, you can practice on squares, cubes, and exponents. Okay, so let's look back at that example. Where was you? Let me see. Where were you? There we go. No, that's not. Oh, that's right. I had it on an open here. So 3x squared times 7x to the 3rd. What would be that answer? Can anybody tell me how I would simplify 3x squared times 7x to the 3rd? What would be our answer? Can anybody help me? 3x squared times 7x to the 3rd.
Would
Is
it
it going to be
21 minutes?
21/5?
21x to the 5th. Perfect. Why? Because you look at the 3 and the 7. 3 times 7 is 21. And then you look at the x squared and you look at the x to the 3rd. X squared times x to the 3rd. They have the same base, so we add the exponents. 2 plus 3 is 5. So since we're multiplying, remember what multiplication means, right? So if we got 3 times 4, right? We can write it as 3 times 4 right next to each other. So if we have 5x, that means 5 times x, right? So, and then we also got to remember, it doesn't matter what order. 3 times 4 is equal to 4 times 3. So since we're multiplying all these together, doesn't matter what order you put them in. So we did the 3 times 7 first, which is a 21. Then we did the x squared times x to the 3rd was x to the 5th. Then we just put them together, 21 x to the 5th, because this means 21 times x to the 5th. Okay. Now, watch this. Listen, and this is just me because I want you to pass this exam. Okay, say we get that problem that I just showed you, that study guide. Say you get that again, right? Oops, not that study guide. Where there you go. You get that, right? Mr. Tinsley, I can't remember my exponent rules. I don't know what I'm doing. Okay, well, if you didn't practice enough, again, your calculator. If I can't say this a million times, is your friend. Watch this. Watch what I do. I can put this exactly the way I see it. So 2 to the 9th. Now I can put my multiplication just so it look just like that. 3 to the 5th times 2 to the 4th times 3 raised to the 2nd power. Right? So I get my answer. Bang. That's a big number. Hey, all you trying to find out is which of the multiple choice is equivalent to that. Right? So just go down to multiple choice. 6 to the 20th power. Were they equal? No. 6 to the 20th. Well, if 6 to the 20th is not it, you know 6 to the 24th is not it because that's even bigger. So go to the next one. 2 to the 13th times 3 to the 7th. Is that equal? No. Go to the last one. 2 to the 17th times 3 to the 7th. See if we get the same thing. Ding, 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 ding. Done. That's no exponent rules. Remember, one of the key things I want you to understand is that the multiple choice, one of those are your answers. So here, when we want to simplify, we want to find which one is equal to it. So we could just go down each one, use our calculator without even know any exponent rules. I got my answer D. Now, as a math teacher, I want you to know your exponent rules because it's very important for algebra. So if you're going on to community college, going on to get your bachelor's, going to any training programs, going to any nurse programs, you need to know your exponent rules. Okay? That was the quickest hour ever. Wow. Wow. And one more example that somebody sent. Let me find it. Hold on
It's
for one
because you say you're having fun, I'm gonna throw up.
Oh, this is the one. This is the one right here. 3 or 4 people had a problem similar to this. It wasn't the same problem, but it says, what equation best describes the relationship in the total cost C and the number of hours of lesson? What? This looks like, can anybody even attempt to solve this problem? Do you even know? Does anybody even know where to start? Which equation best describes the relationship between the total cost and the number of hours of lessons H? Does anybody even know where to start on this problem?
We're gonna add it
Why would you add it? Tell me why you would add it.
because it wants the total cost for C.
Okay. No, that's not it. Because the key word is what?
I would divide it.
Equation.
Equation. This is why when people read word problems, they get all confused. I heard adding, I heard subtracting, I heard dividing, I heard multiplication. Listen, no, what do they want? They want an equation. So if they want an equation, I knew what 2 things do I need for an equation of a line? What 2 things do I need for an equation of a line? Can anybody tell me what 2 things do I need to know for an equation of the line?
How many hours in total dollars?
Nope. Okay, so if I wrote this down, what does the M stand for?
No,
Slope.
What does the B stand for?
the y-intercept.
The y-intercept. So understand what I just told you. They're asking for the equation of the line. Right away, if you see anything that asks for the equation of the line, you need a slope and a y-intercept. Right there. If they ask any question that they ask the equation of the line, you need 2 things, the slope and the y-intercept. Mr. Tinsley, how do you, hold on, we found the slope from an equation. We found a slope from a graph. We found a slope from 2 points. How do you find the slope from a table? Like, how do you even do that? Can anybody tell me? because this is a difficult problem. This problem, most people will spend 8 to 10 minutes on this problem alone. What I want to show you is this. The first thing you're asking yourself, hold on, they want the equation line. Okay, well, Mr. Tinsley told me if they ask for the equation line, I need the slope and the y-intercept. Okay, well, how do I find a slope from a table? What you should know is any table, this is your X, this is your Y. So they give you the hours and they give you costs, but this is also 2 points.
Okay.
Okay, 2 points. Now, to find the slope, you should know y2 minus y1 over x2 minus x1. So my y2 is 90 minus 6750 over x2 is 3 minus x1 is 2. 90 minus 67 is 22.5 over 1. So I know my slope is 22.5. So I know it's not A, I know it's not C. Why? Because I know my equation should look like this. Y equal 22.5x plus or minus something. Because I know the slope is what's in front of the variable. But what they did is they changed this. What you know is C is going to be Y, and your variable, what's going to change is your X, your H. So instead of Y equal 22.5x, it's C equal 22.5H. So you know it's not A or C. So now at least you're down to 50%. You got a 50% chance to get this right. So how do you find the y-intercept? Again, you take the slope and you take a point. But Mr. Tinsley, that's a whole lot of work. Yes, it is. Look how long this is taking me. I'm trying to show you. First of all, I had to identify this as a table and I have 2 points. Then I had to plug it in to the slope formula to get my slope, which was 22.5. Then I eliminated 2 of the answers. So already I'm on 3 to 4 minutes because I'm the teacher and it's taking me 3 to 4 minutes, right? So now, okay, so how do I find the y-intercept if I'm given the slope in a point? Okay, this is a guaranteed problem on your exam. Now, this problem is way more difficult than anything that you're going to see on the GED, but the steps are still the same. Let me show you. Let me change the blue. Y equal mx plus b. I'm going to take this point here, the 3 and the 90. So my y is 90 equal my slope, but I just figured out is 22.5. My x is 3 plus b. So we got 90 is equal to 66 and 1.5, so 67.5 plus b. Again, how do I get b by itself? I'm going to subtract 67.5 from both sides. And I get 22.5 is equal to b. So my y-intercept is 22.5. My slope is 22.5. My answer is that. Mr. Tinsley, what? I'm never going to understand that. I'm never going to be able to do that. Oh my God, Mr. Tinsley, my head is about to explode. That's why I'm telling you, one of the most important sections of my ebook is how to solve an equation of a line given 2 points. Because then you don't have to do any of that work. All you got to do is grab your calculator. Watch this. I'm going to show you that problem just took us 7 minutes. Watch this. Data. Oops, let me clear all this out first. Let me clear everything out first. Hold on. Watch this. It's going to take me less than a minute. Watch this. It's literally going to take less than a minute. It might take less than 30 seconds. Watch this. Once I realized that they want the equation of the line, once I realized that the table is giving me several points, it's giving me 4 points, all I'm going to do is go to data. My first X is 2, enter, 3, enter. I got my X's in. Hit my right arrow, put my Y's in. 67.5, enter, 90, enter. I now entered my 2 points. Second, data, 2 variable, calculate, and go down to A and B. Look at that. Now I have my slope and there's my y-intercept. My A is my slope. My B is my y-intercept. So now I know the slope-intercept form is y equal mx plus b. I'm just plugging in what I know. My slope is 22.5, so y equal 22.5x plus my b is 22.5. 5 seconds, 15 seconds, 30 seconds it took C. Listen, if you are going to learn anything from my ebook and this calculator, it's how to do those linear equation problems. Why? Because you just save 7 to 10 minutes in 30 seconds. So let me clear it first and let me maximize the screen. So if you go back in, you'll be able to do all the key presses that I just did, and you'll be able to see it. Oops, I can't get everything in the screen. There we go. And let me take a picture of that. Why? Because any problem, they ask you for the equation of line and they give you a table, you don't have to do all that work. So let me do one more example before we leave this evening. Let me clear this out. Let me do one more example where if you're given a table, where we can get the equation of line. Where are you? I don't see you. Let me see. Let's do one more. Let me find it. Hold on for a second. I've been tutoring a whole lot this week. Make sure if you schedule, please schedule your one-on-one. I got a lot of one-on-one scheduling. Schedule. My schedule is filling up fairly quickly. So if you test in the next 2-3 weeks, make sure you reserve that spot. So watch this. I'm gonna show you something. Ooh, what just happened? I don't know why that didn't work. Watch this. One of the hardest problems on the test is now easy. Watch this. It says, I'm gonna show you. And I showed this before in class before, but you gotta understand what you're looking for. So right there, they're asking for a table. They gave you information about tree 1 and tree 2. The first question, oh, they did it again. Okay, all right, let me try to go to the website. Hold on, GED. There we go. For some reason, my PDF is not working today. So let me put this on here. Now, this is a practice test. It's about 10 questions. I love it. It's given by GED. It's a practice test, and I just try to screenshot it for the PDF. So here, they gave you this information. And this first question, they want you to plot tree 2 on a coordinate grid. You're always going to have to plot an ordered pair, always. But this is what I'm talking about. Look what they're doing. The scientist creates an equation that models her data for each tree so she can predict the diameter in the future. Complete a linear equation that fits the data for tree 1, where X is the year and Y is the trunk. Click on the variables and number you want to select and drag them into the boxes. Most people are going to look at this and say, oh my God, what do they even want? What I want you to understand is, first of all, they tell you what they want. They're asking for a linear equation. Once they ask you, once you know that they want the equation of the line, you got to find the slope and you got to find the y-intercept. So you can either do it manually, the way I just showed you, or you can say, hold on, data from tree 1. I need 2 points. I'm going to grab my calculator. Let me clear it first. Let me save it and let me clear it. I'm going to grab my calculator. I'm going to hit my, oops, let me clear that too. Sorry about that. Data cleared all. So we can start right from scratch. So I'm going to grab my calculator. I'm going to use my 2 points from tree 1. All you had to ascertain is they want the linear equation from tree 1. Boom. My X's, 1 and 3. 1, enter. 3, enter. That's my X values go in the first column. Goes in my second column are my Y's. 18.6, enter. 19.2, enter. Does everybody understand what I just did? That's easy. First column, my X's go. My second column, my Y's go. So you should be able to see the 2 points. 1 and 18.6 and 3 and 19.2. That's not hard at all. The second step, I detail it right in my ebook or go back over this video and watch it slowly. Second, data. We have 2 variables, X and Y. My X data is in my first column. My Y data is in my second column. It's already selected for you. Go down to calculate and go down to A and B. Lowercase a and lowercase b. What you should see right now is the slope is 0.3. We did no work. My y-intercept is 18.3. So that tells me my equation is going to be y equal 0.3x plus 18.3. Boom. So now all I do is I drag and drop. Y equal 0.3x plus 18.3. Done. That's not even a minute. So let me put the calculator back on the screen real quick. Let me clear it out. Let me maximize it so you'll be able to see all the steps. But this is what I'm telling you. For the harder problems, like the equation of a line from 2 points, or the equation of a line of the perpendicular line, or the equation of a line with the parallel line, or what's the equation of a line from 2 points, you can use your calculator. For the quadratic equation, you can use your calculator. For all the most difficult problems, if you go through that ebook and do those practice problems, the harder problems that you're going to get, you'll be able to use your calculator. And those 6 or 7 minutes that you're going to save on those most difficult problems, now you can focus on the easy and medium problems. But that's I can't make it any simpler than that. I can't make it any simpler than that. That question.
To get in there, we have to press the mode button to get into that.
No, no. So let me do it again. Let me clear everything out. Clear. Oops, data, clear all. I still didn't clear it all. Come on, Jeremy. I know the time's running out. Clear. So to get to this, we're still not clearing out. To get to there where you can put those in, you hit data.
Data.
Boom. It opens up these 3 columns. Your X's are going to go in your first column. So we're going to hit 1, we're going to hit enter. We have to put our second X, 3, enter. Then we're going to take our right arrow, we're going to move over to the second column where our Y's go. 18.6, enter. 19.2, enter. We now have both our points entered into the calculator. Now all we got to do is second data, 2 variable, calculate, and then look for A and B.
Go to the two variable.
2 variables. So hit your down arrow to 2 variables, hit enter,
Uh-huh.
and then go down to calculate and hit enter. And then you're going to hit your down arrow until you see a lowercase a and a lowercase b. So the only questions listen, I'm guaranteeing they're going to ask you this question. They're going to either ask you, what is the equation line from 2 points? What's the equation line from a table? Or what's the slope from 2 points? You can type them in and the calculator is going to give it to you. So out of those 3 possible, they probably going to ask you 2. Easy. A is your slope, B is your y-intercept. All you got to know is how to put that as the equation of the line. Y equal 0.3x plus 18.3. Done. Guaranteed you're going to have that one. Guaranteed. So learn how to put those 2 points into your calculator to solve for either your slope or the equation of the line. It's a guaranteed problem. I'm telling you, it's guaranteed. It's one of every single practice GED test that I've seen for the since 2014. They're going to have it. And it's one of the most missed questions. So again, those are the types of things. So again, in this class, in this GED Math Mondays, I try to identify what I know you're going to see on the exam. So what I want to show you here is, even though they gave you all this information, they gave you 3 paragraphs of information, they gave you 2 tables, all you had to identify first was what's given. What do they want? They want a linear equation. They want the data from tree 1. Okay, I'm not looking at tree 2. I'm only looking at tree 1. If they want the equation of a line, I know I need the slope and y-intercept. I need to know that a data in a table is the same as points. So for example, this is the same as 1, 18.6. This is the same as 3, 19.2. This is just a different way they're showing you the points. In this way, it's they're showing you a table. In this way, they're giving you ordered pairs or the points. You have to know that these are the same thing. You have to know that this right here is 1, 2, 3, 4, 5, 6, 7 different points on this graph. So how do you know that? This is where here on this previous question, they wanted to see if you knew it. So here, tree 2, year 3, and year 11. They want to see if you know how to grid. They gave you all this information. All you do is looking at tree 2, year 3 is 3 and 12. So 3 and 12. That's the first point. My second point is year 11. Year 11 is the trunk dam is 14.4. 11 and 14.4, which is about right there. That's 2 guaranteed problems where you're going to do ordered pairs, equation of a line, guaranteed every single GED exam. I'm guaranteeing you. But what happens is people get so intimidated by the word problems. Oh my God, I can't do a word problem. No, listen to what I'm telling you. When you see a problem that's difficult, I want you to take 3 to 5 deep breaths. And I want you to say something positive. What's given? What do I know? Okay. Identify what you know first. That's going to give you the roadmap of what you need to do. By identifying, and that's in this one, the location on a coordinate grid. That means I need to plot 2 points. In the second problem, a linear equation. They ask you, what is the linear equation? Oh, I know what. That gives you a roadmap of what you need to do. By identifying what's given and what they want to know will give you the roadmap to solve every single problem on this exam. And then what did I tell you? If you think it's too hard, flag it for review, skip it. Don't waste 5-8 minutes on a problem. Do not. If you know you can't do it, pick A or D, move on to the next problem. Don't even waste your time. Now, what I mean by don't waste your time is immediately. First, finish the exam first. And then come back to those difficult problems. I don't mean skip it and don't do it. Finish the exam first, then come back to those problems that gave you difficulty. Okay?
Mr.
Any-
Tinsley,
Yes.
can I still get the same answer if I used 5 and 7 as my X and 18, 20 as my Y?
Did you just hear that question? I love questions like that. Oh my goodness. His question was, can I use any 2 points? I'm going to use 5 and 7. You can use 1 and 13. You can use a 9 and 11. Remember, a linear equation is a constant rate of change. It doesn't matter what 2 points you use. And I'm going to prove it to you right now. That's a wonderful question. Let me clear everything out. Let me clear this. And let's go to work. You said 7 and 9?
Yes.
Okay, we're going to use 7 and 9. It doesn't matter what 2 points you choose. Okay, my first X is 7. My second X is 9. Right arrow, second column. 20.4 is my first Y. Enter. 21 is my second Y. Second data, 2 variable, calculate. Bam. 15 seconds. A and B. Stop playing. Slope, y-intercept. Slope 0.3, y-intercept 18.3. 15 seconds.
That was great.
Listen what I'm telling you. Take the 2 weeks to go through that ebook. I'm telling you, you will finish the exam in 40 to 60 minutes. You will finish with an hour to spare. Why? Because you're going to hear Mr. Tinsley in your ear. If it's hard, flag it for review, skip it. Do the easy and medium ones. Finish the exam, You'll finish the exam in about an hour, then come back. You'll have an entire hour to finish, between 40 minutes and an hour to finish the difficult problems. But again, know the ones you're going to get. Every one of these GED Math Mondays are giving you questions, the type of question that you're going to see. You're going to see an area and perimeter problem of a rectangle, guaranteed. You're going to see an area or circumference of a circle, guaranteed. You're going to see a volume of a rectangular prism, the volume of a cylinder, the volume of a sphere. You're going to see them, guarantee you. So all you have to do is practice, practice, practice. Now, on my site, it's free practice. You don't got to pay for it. Once you buy the ebook, it's free. Practice. I got enough practice for weeks. Practice until you can see every type of area problem. Practice until you see every type of circumference problem. Why? Because listen, this GED, this diploma, you got so much rested on it. So what that means is something has to be sacrificed. If you can't go to a party, don't go to that party. Because I'm telling you, you give me 30 days, an hour to an hour and a half a day, you're going to pass your GED math exam. And I don't care how many times you failed the exam. You're going to pass. Once you bought that ebook, once you logged in to this GED Math Mondays, I will not allow you to fail that exam. You will pass that. I will work with you until you pass that exam. Period. But what I need from you, spend that 2 weeks in that ebook and practice, practice, practice. I don't care if you use the Kaplan book. Now, what I did was I tried to put everything in one place. So if you want to work on the area problems, I got a place for you. If you want to work on quadratic equation, you can work on it. But I don't care what resource you use. Think of the steps. Hard problem. Deep breath. What do I know? Okay, I have a square. I know how to find the area of a square. I have a circle. I know how to find the area of a circle. Okay, well, I only need the shaded region. So you know what? That means I'm going to take the area of the circle and subtract that from the area of the square.
10 o'clock, right? 9.
Okay, so that's the steps I want you to take. Again, it's not going to be difficult. You go through that ebook, do my practice problems, you're going to pass your exam. I'm telling you.
Mr. Tinsley, have you
yes.
seen a trend? Because I've taken it twice now, and I think I told you I went from a 127 to a 142.
Okay.
But I've been taking it at home.
Okay.
And so I think this next time I'm going to do it in a center because I'm a hands-on person. So having that paper and the physical calculator, I think, is what's going to push me over the passing point or maybe get me a point or two closer. Have you seen a trend in your students in which way they pass, from home or in a center?
So this is what I can tell you. Every single person I work with that passed the exam. But what I can tell you is for the people that took it in a center, they felt more at ease. Why? Two things that happen. First of all, when you take it, I guess I don't need to record all this. Let me stop the recording. Hold on.